Alrighty, guys, here we go. This is pre-calculus, chapter 8, section 3. Homework page can be 571. Now, section 3 has to do with the inverse of square matrix. So you're going to find the inverse of 2 by 2s and 3 by 3s. And ideally, you want to do this section after section 8, chapter 8, section 4. Okay? So you want to do section 4 first and then do this section 3. So the book kind of has it a little backwards, okay? So what we want to do in this section is find inverses of 2 by 2s and 3 by 3s. So I'm going to show you how to do that. And then also use inverses to solve equations that have to do with, like, for example, matrix and then systems of equations, okay? So for a 2 by 2 is very simple. For example, let's say I have a matrix A, okay? Matrix A has elements that is A, B, C, and D. Well, the inverse is rather simple, okay? Um, it is 1 over the determinant of A, and I call this my flip and flop rule. It's really easy for a 2 by 2. Flip and flop. So first you find the determinant of A, you put 1 over that number, whatever that number is, determinant, okay? And then you're going to take A and D, and you're going to flip the numbers. In other words, you're going to just kind of switch their locations. You're going to put D up here and A down here. And then for B and C, you're not going to do that. For B, you're going to take the opposite of whatever it is. And same thing with C. You leave the number there, but you just change the signs. Okay, so we'll do some example on that. Now, 3 by 3s is a little bit more complicated, but the idea is first you find the determinant. You're going to put 1 over determinant. Okay, then you're going to go to every element. Okay, so one at a time. You're going to go to the element and cover up the row and column and repeat the determinant of whatever is left over that you see. Okay, then in step 3, you're going to change the rows to columns of the answer that you got. And then the last step is you're going to change the sign of the diamond shape. In other words, element number 2, element number 4, 6, and 8. Okay? So we'll do that for you. And then we're going to use matrix to inverses to solve equations, okay, systems, or just plain old matrix. Okay, so for example, if you have a 2 by 2, like this guy here. So for example, let's say our A matrix is 8, 3, oh, sorry, 8, 9, 8, 9, 3, negative 1. Okay, so 8, 9, 3, negative 1. So first thing is we have to find the determinant of A. So if you remember, the determinant is 8 times negative 1 minus 9 times 3. So the determinant is negative 8 minus 27. So determinant of A is negative 35. Okay, so make sure you have that. So that means our inverse, so this symbol, this negative 1 symbol means inverse, okay? It doesn't mean a power, just a symbol means inverse, okay? So you take the determinant and you put 1 over that, 1 over negative 35. But remember, you can have a negative down here in the denominator, so my negative is going to come up, and I'm going to have 35. So it's really negative 35, but I leave the negative on the numerator. Okay, now to complete the inverse, all you got to do is take A and D and switch their locations. So negative 1 comes up here, 8 comes down here. You see what we did? We switched the locations of 8 and negative 1. Now, see this 9? It's a 9, so I'm going to make it the opposite of 9, so negative 9. Now, this guy is 3, so I'm going to do the opposite of 3, negative 3. That's it. I am done. Okay? So now these two are inverses of each other. So what's going to happen if you want to check, okay? This is just to check. You don't have to do this, but in case you want to check, well, the idea is when I take two items that are inverse of each other and I multiply them together, I'm going to get this. I'm going to get what's called the identity, or in other words, 1 in matrix language. Okay, so if you want to, it's not a must, but if you want to check, then you can multiply this guy to the original, or vice versa, it doesn't matter. So -1 over 35, I'm going to check now, just to be safe. So -1, -9, -3, and 8. I'm going to take this, I'm going to multiply it with the original, 8, 9, 3, -1. Okay, now I'm going to try and multiply these two matrices. Now, if you remember back in the earlier section, to multiply matrices, you take the first row, -1 and -9, you stand it up, multiply like this. Remember that? So you get -8 and add, okay, -27. Okay, so now my answer is -35. When I reach over here, second column, I'm going to get -9 and add 9. So when I do that, I get 0. So now that I'm done, I do my second row, this second row, -3, 8. I'm going to multiply 8, 9, 3, -1. Okay, remember how I multiply matrices? Okay, so when I multiply these, I get -24, add 24, which is 0. Again, I reach all the way over, I get -27, add this way, -8. So -35. Okay, now remember this determinant that was in front, -1 over 35. Now multiply, this is a scalar. I'm going to multiply -1 over 35 to every element. What's -1 over 35 times -35? That's 1. What's -1 over 35 times 0? Okay, I'm going to multiply like this. I'll multiply like this, distribute basically, I get 0. I'm going to take this and distribute, I get 0. Distribute again, I get 1. See? So this is how I know my inverse is correct. When I multiply two matrices that are supposed to be inverses, I do get what's called the identity. So I know this is correct. Okay, so I just checked. Now this is a checking method. You don't have to do it, but if you do, that's how it works. Okay, so let's do another example. Example number 2. Okay, and then we'll do a big matrix. Okay, so example 2, let's say A is 1, -2, 8, -5. Okay, so first find the determinant of A. The determinant of A is going to be -5, or 1 times -5, doesn't matter the order. 1 times -5, -5 times 1, doesn't matter. I'm going to minus -2 times 8. So I get -5 minus -16, like that. So here, my determinant is going to be 11. Okay, so my inverse now, since my determinant is 11, 1 over 11. Again, remember, if this determinant is negative, just move the sign up. My inverse now is going to take 1 and -5 and switch the locations. -5, 1. Take the other two numbers and just change the signs. Don't relocate them. Do not relocate B and C. Just change the sign. So -2 becomes 2 and 8 becomes -8. There you go. I am done. Okay, so that's how you find the inverse of a 2 by 2. Okay, so now I'm gonna show you how to find the inverse of a 3 by 3. Okay, so let's do that one. Let's say, for example, I have matrix A. Matrix A is this guy, 3, 1, 2, 1, 3, -5, 2, -4, and 7. This is matrix A. So first thing I want to do is find what's called the determinant. Okay? Now, in order to do determinant, right, determinant A, I have to take the original here. If you go back a lesson, okay, you take 3, 1, 2, 1, 3, -5, 2, -4, 7. Find the determinant. In order to find this determinant, I have to copy the first two columns, 3, 1, 2, 1, 3, -4, and then I go down, right? Multiply these guys. Okay, I'm gonna get here 63. 3, 3, and 7 is 63. Then go down, right? I'm gonna add 1, -5, 2 is -10. And then I go down right again. Going down right. 2, 1, -4 is gonna be -8. So my grand total here, 63 minus 18 is gonna be 45. Okay, so now remember we did this before. Going up. 2, 3, 2 is 12. I'm gonna add this way. I'm gonna add, let's see, -4, -5, and 3. So I'm looking at 60. And then going up, 7, 1, 1 is 7. So here I get 79, right? Now, the determinant is 45 minus 79. So determinant equals -34. Remember that? We did that last section. So first I found the determinant. Okay. So then I know that my inverse is going to be 1 over -34. But the negative is going to float up to be 1 over -34. Okay. So now, okay. So first step, find the determinant. Now, second step, I use this nice fancy tool right here. Okay. So the notes, the notes say right here, if you look at the notes that we showed earlier, you're going to cover the row and the column and compute the determinant that's left over for every element. Okay. So we're going to do step 2. What do I mean by that? Okay. For example, the first element I see is the 3 right here. Okay. First element is 3. So what I'm going to do is I'm going to use this fancy tool I got. Okay. I'm going to cover up the row and the column of 3. See that first number 3 there? I'm going to cover up the row and column of 3. Okay. So when I do that, look what's left over. Okay. I get 3, -5, -4, and 7. I have to find the determinant of these 4 numbers left over. Okay. All right. So let's do the work on the side. If you remember, 3, -5, -4, 7. The determinant is 21 minus 20. So that's 1. Okay. So when I cover up the row and column of my first element, which was 3, the leftovers were 3, -5, -4, 7, and the determinant was 1. So my first number is 1. Now, I have to do that same process 8 more times. So all 9 of these numbers needs to be done that way. So here's my fancy tool. I'm going to go to the next number right here, the 1. I'm going to cover up the row and the column of this number 1 right here. Okay, cover up the row and column. Okay, now look what's left over. Left over is 1, -5, 2, and 7. What's the determinant here? The determinant is 7 minus -10. So hopefully you guys remember how to do that. That comes out to be 17. So my next answer is going to be 17. Okay. Next is the 2. All right. See that 2 right there? I'm going to cover up the row and the column of 2. So here's the row and the column of 2. Look what's left over. Left over is 1, 3, 2, -4. So finding this determinant is -4 minus 6, -10. So hopefully you guys remember how to find determinants of 2 by 2s. Those are pretty simple. Okay? So now we did the 3, the 1, and 2. Now we have to do 6 more times. Okay? Every element needs to be done that same process. Okay? So this fancy tool, I'm going to cover up the number 1 here. Okay? Element. Okay? So cover the row and column. Okay? So now look what's left over. I'm left with 1, 2, -4, and 7. You can make this tool yourself. It's nothing fancy. Okay? 7 minus -8. So I'm looking at 15. So that's my next answer. My next answer is 15. Now comes the 5th number. I'm going to cover up the row and column of 3. Okay? When I cover that up, I'm going to get 3, 2, 2, 7. So finding this determinant is 21 minus 4, right? If you remember that, that's 17. So I'm going to have 17 here again. Then the next number is -5, so cover the row and column of -5. When I do that, I'm going to get 3, 1, 2, -4. So I get here -12 minus 2, -14. Perfect. So that's my next -14. Okay. Now I got 3 more to do. Okay. 3 more to do here. So let's see. When I cover up the row and column of 2, I have 1, 2, 3, -5. So here you get -5 minus 6, -11. So I put that here, -11. So whatever element you cover up, that's where you put the determinant of the 2 by 2. Okay, so now -4 is left next, right? Cover up the row and the column of -4. Alrighty, I get 3, 2, 1, -5. So this determinant is -15 minus 2, -17. Ooh, just a coincidence, okay? This whole column is all 17s, but nothing special. Nothing tells you about that. It's just a coincidence, okay? Now, doing the last number, hopefully you're able to do that on your own. Cover up the row and column of 7. Look at that. You get 9 minus 1, 8. There you go. So what we did was we cover up the row and column of every element using this guy, okay? And then the leftovers gives us a determinant of these, okay? Now, we're not done yet, okay? We're not done yet. That was only step 2. But the other 2 steps is very simple. The next step says, hey, I need to change these rows to columns, okay? Very simple. So -1 over 34, very simple thing to do. See this row 1? Row 1 goes across. So what I'm going to do is I'm going to take these guys, I'm going to make it go up and down. So see, this is a row. Now I'm going to make it stand up, become a column. Okay, don't forget that step. Look at row 2. Row 2 is 15, 17, -14. 15, 17, -14. So it was a row. I made it stand up and down to be a column. The last row is -11, -17, and 8. Okay, again, it was a row. I made it stand up. Okay, now here's my official last step. Okay, my last step is I'm gonna take the diamond shape. Okay, if you remember like a diamond shape, or like if you're playing baseball, you watch baseball, it's the bases. Okay, see those guys? All right, basically element number 2, element number 4, number 6, and number 8. I'm going to take these 4 places and I'm going to change the signs. Whatever they are, I'm just going to change their signs. So -1 over 34. Okay, I'm going to leave everything else the same. 1, leave it alone. 15 now. 15 becomes -15. -11, keep it alone. Keep it the same. 17, see this 17 becomes -17. This 17 in the middle, leave it alone. this negative 17 becomes positive 17. Again, we're changing every sign in the red circles. Negative 10 stays. Negative 14 becomes positive 14. And the last one, 8, just stays as 8. And so now I'm officially done. Okay, this is my inverse of a 3 by 3. Okay, beautiful. All right, good luck with that. Okay, hopefully you're able to do that. And what helps is you get this fancy tool right here. You know, you make it on your own, whatever you want. Okay, just like out of paper or whatever. Okay, all right, have fun. Try it on your own.